Here we go. So 9.3, right triangle similarity. Okay? So similarity within right triangles. This is page 254 of your student journal. All right? And the first thing I want you to do is kind of taking a look at this. I want you to read through the right triangle similarity theorem here, and then I want you to read about geometric mean on the bottom. Okay? So those two pieces. Make any notes you need. Kind of help clarify and have any questions ready. All right triangle similarity theorem. So first thing you have to be able to do when you're looking at this, if you didn't notice, you have to be able to identify the three different triangles. Okay, so you'll be given a picture. Kind of zoom in on this. You'll be given a picture like this one here of a triangle, say ABC. Okay? And within that big triangle, it's important for you to be able to see the two smaller triangles, ACD and CBD. So they've separated them there. Now, I don't expect you to always separate them, but being able to see that these two smaller ones make up the bigger. All right? Those three triangles are similar. We can prove they're similar based upon, and I'm hoping you just don't take word for it. I mean, so why are they similar? Well, this one has a right angle, and it shares an angle in common with the big triangle. Therefore, this triangle is similar to the big triangle by angle. And the same thing occurs with this triangle, and or this angle and that angle in the big triangle. Okay, and you can go through. Well, if two triangles are similar to the same triangle, then they're going to be similar to each other as well. All three triangles are similar. Okay? And that's what that states there. All right. Now, we use geometric mean to help find side lengths of those triangles. And it's important for you to understand what geometric mean is first. So mean is like an average. When you're dealing with the geometric mean says if I have a over x and x over b, that would give me, if I cross multiply, x squared equals a times b. So cross multiplying there. And if x squared equals a times b, it really means x then. I take the square root, I get x is equal to square root of ab. Well, how does that apply? Well, if you turn the page to page 255, there's the geometric mean altitude theorem. And one of the relationships when you're dealing with these three right triangles, this only works when you have similar right triangles like this, is that this length right here, CD squared, is equal to AD times BD. What does that have to do with geometric mean? Well, really, that means this length, if I was to call this length X, and this length A, and this length B, that would mean x squared is equal to a times b, or x is equal to the square root of ab, which means this length right here is the geometric mean of the lengths of these two segments. Okay? Please understand that when we're talking about geometric mean, I usually just jump right to here, but you are still dealing with this ratio, a over x, is equal to x over b. Okay, this ratio equal to that ratio. I guess that's a proportion. So you're dealing with that proportion. Okay? How many are with me so far? All right. There's the geometric mean leg theorem. Okay? Tell your neighbor how this theorem up here differs from that theorem down there. Be specific about it. All right, how do they differ? Yeah, this one deals with legs, this one deals with altitude. Okay, this one says I'm dealing with the altitude of the big triangle. This one says I'm dealing with the legs of the big triangle. So here's a leg of the big triangle. Okay, whereas up here, this x is the altitude of that big triangle. Okay, so if I focus in now on the legs, notice the geometric mean You're taking geometric mean of different items there. You're saying if I want to find AC, which is this bottom one, I am finding the geometric mean of AD times AB. So this length times that length. Okay, so remember, we can write this as, if I was to call this X, and this A, and this length B, we could say that X squared is equal to A times B, which means X is equal to the square root of AB, which once again is your geometric mean. Okay, how many are with me? Carla looks pumped. Good job, Carla. Pumped up over there. Okay? Now, if I were to deal with the shorter leg, and I'm dealing with the shorter leg over here, and let me get a different color. Dealing with the shorter leg of that, I'm now saying I'm going this length, dB, times this entire length, AB. So I've got CB squared is equal to DB times AB. So again, if I use the geometric mean, and you have to differentiate between these x's, so let's call this x sub 2, the second x value, and this would be our second A value, and our B value is the same still. Okay, that would say that we called this x squared is equal to A times B again, or A sub 1 and x sub 1. Okay, once again, you get x squared is equal to the square root of AB. So it's the geometric mean. Now, I want you to tell your neighbor what an easier way to remember which one goes with which. I mean, that's a lot of formulas there. How is it easy to remember these three formulas? You've got to come up with some kind of plan to remember them. Okay? Yes, this would be x equals square root of AB. Good job. Sorry about that. Well done, Maddie. Okay, tell your neighbor what you come up with there. How can you remember them? Okay, thoughts? By the way, right now the score is 1 and 1. Everyone else has 0. But what are our thoughts? Yeah.
The legs is like a triangle. I don't know, like it's not that difficult to forget. I mean, it's pretty like when the legs.
Maddie.
Could you say like the middle length for the leg one?
Okay.
Like the middle length is equal to the square root of the shorter length times the longer length.
Okay, so this length right here is equal to the shorter times the whole. Okay, how does that help if you're differentiating it between this one?
Because, you could say like the hypotenuse is equal to the base angle times like a full angle. I mean the hypotenuse is equal to the base length times the full length of the hypotenuse of the big triangle.
All right. Hey, how about you guys do this? Focus in on the legs. In a triangle, in this right triangle, there are two legs. One is longer than the other. Okay? Now, try to relate that to this formula. KJ? Good. So if we take a look at this leg right here, okay, this leg is going to go with the longer length because it's the longer leg. And this leg is going to be with the shorter length because it's the shorter leg. And they're both multiplying that, either the shorter length times the hypotenuse times the entire length, right? Or the longer length times the entire length. Okay? All right. So if you're like, that still confuses me, well, then you're going to have to memorize the formulas. Or you're going to have to do everything in the other method I show you. It'll be up to you. Okay? This one right here, the altitude, just splits the two pieces apart. So that times that. It takes the two lengths, split them apart, and you take the root of that. All right. That is geometric mean. That's how we use it with these triangles. Now, I will tell you there's also ways that we use it when you're dealing with other type of graphing and stuff. We don't get into any of that. But I'll probably put something on my website if you really want to explore that. I want to take a look at your extra practice. I'm going to turn to that page. And on this page, we're going to use exclusively geometric mean to go through these problems. Okay? So this is page 256. I want you to go ahead and answer questions 1, 2, 3, and 4 with your groupies. All right, there's 1 and 2. Carla? Hold on, let's go. Any questions on 1 and 2? This triangle, that triangle. So you're separating your 3 triangles. Okay, so the big and then the 2 small. Okay. So what's your question, Carla, on 3 and 4? Let's go ahead and leave it in simplest radical form on number 3 and 4. Good question. So I'm going to write it in proportion form first, just so that we get used to seeing that form. Even though if I'm actually finding the geometric mean, I'm really probably not going to do that. But you're going to see it in your text like that. You may see it in your quiz or online assignments like that as well. So if this is A and that's B, that would become 2 over x equals x over 6. Okay, those pieces would get substituted in for A and B. And then you cross multiply to get x squared equals 12. If x squared equals 12, you'd have x equals root 12, which we know is 2 root 3. Now, reality is if I'm doing these problems, I'm probably just jumping right to this step. I'm not writing that proportion every time. But I do want you to know that's how you write the proportion. Make sure that you can write it like that. So if you see it, you know that that's what we're talking about with geometric mean. So this would be 5 over x equals x over 45, which is x squared equals 5 times 45, or 225. So x is 15. All right. Questions there? Okay.
So the first letter, the first number will always be A, right?
Yeah, we'll call that A and B.
All right.
Yeah. Okay. Okay, I want you to utilize the geometric mean and your different theorems there to find the lengths of the indicated, find the value of the variable in each of the triangles down below. So start with 5 and 6. We'll go through those here in a minute. Work together. Hey, volunteer to tell me how you did number 5. Yeah, Drew.
I put down x squared equals 9 times 16.
Okay, so you're saying that good, geometric mean altitude theorem. So here's the altitude. That means this length is equal to the square root of those two multiplied together. 9 by 16 happens to be 144, so x is 12. Well done. How many got 12 there? Good. Okay. Well, number 6. Yeah, Maddie.
I first put down y squared equals 9 times 2.
Y squared equals what?
9 times 2.
9 times... Not quite. It's close.
9 times. Okay.
9 times 11, yeah. So we take the longer leg of our big triangle is equal to the longest part of that segment times the entire segment. So 9 times the entire, which is 11. So we get y is equal to root 99, or y equals 3 root 11. That's good. Okay. How many got that one? Okay, questions on those? Okay, try the next two there. Make sure you're asking as I'm cruising around if you need help. Hey, these are a little tougher. Number 7, that must be what the T stands for. Tough. I'm thinking. All right. Who has an answer for number 7? Maddie, you got it? What did you get?
I got T equals 343.
Okay. Anyone else?
No.
KJ? Okay. I'm just seeing what you guys got. Okay. Yeah. Okay. What'd you get?
I got 7.
Okay. Anyone else? Yeah. Yeah. Okay. Well, let's try it out here. Hey, when we're dealing with this, we're doing the geometric mean. So, anyone want to give me their equation to start out with? Got to mark down points here. Oh, just 2 of you. Okay. Well, I called on Maddie last, so Carlo, go for it. Okay, so you're saying this side squared is equal to the square root of the shorter, because it's shorter leg, times the longer. Good. That's right, yeah. Okay. Total sweet. All right. Anyone tell me what to do from there? Yeah, Alexis. Oh, I thought your hand was up.
Well, yeah, I didn't do this thing, but would you do,
All right. Carlo? Okay. 49 squared. Is equal to, okay, and so 2,401 is equal to 7 times t. Yeah.
Divide by 7.
All right. So t equals
343.
343. Well done. It is 343. Yeah. Don't have to add the extra 7 on there because we're already solving for t. No. Okay. Good job. Questions on it? All right. Number 8. Volunteer to give me their formula. Came up with. Cynthia.
3a plus 4.
Okay. 3 times a plus 4
Equals 6 squared.
equals 6 squared. So you're finding the geometric mean using your altitude there. Okay. All right. Jordan, what'd you do next? Okay, 3a plus 12, distribute there, equals 36. That's one route to go, for sure. What's next? Yeah, Alex?
So I subtracted 12 from 36.
Okay,
And got 24 equals 3a.
and so what's a?
So it would be 8.
A would be 8. How many got 8? Well done. All right. Any questions? So we have plenty of practice using geometric mean now. Now I will tell you it's not always easiest to use geometric mean. All right? So sometimes you can use it. If you decide to do everything the way I'm about to show you, that's fine as well. It'll be completely and entirely up to you. Here we go. Here's a nice problem for you. You can add it to your somewhere in your notes there, maybe on one of the previous pages. Okay? A roof has a cross-section that is a right triangle. The diagram shows the approximate dimensions of this cross-section. find the height h of the root. All right, get it copied down first. All right. Now, here's the deal. You could use geometric means to solve this. It could take quite a while because really my route I would end up going is I would have to find maybe like this little length here or this little length here in order to be able to multiply that by that to get that. You guys with me on that?
Yeah.
Okay. So sometimes it's easier to go through and maybe just list your proportions. We still know that similar triangles have proportional sides, correct? Okay, so if I were to say, look, I've got a small triangle, a medium-sized triangle, and a large triangle. Okay? Now I'm going to make like this little table real quick, just like a tic-tac-toe board table, something like that. And then I have 3 sides to each triangle, hence the word triangle. Okay? So I have 3 sides. Okay, I guess that would be 3 angles, but that's okay. 3 sides, A, B, and C. I'm going to call my triangle sides A, B, and C. Why A, B, and C? Because like AB, A squared, B squared, C squared, that type of thing. Okay, that type of triangle. How many are with me? Not tough so far. So if I just take a look at the small triangle, I know that the smallest side, and I'm going to call A my shortest side. I know that the shortest side of my small triangle I don't have a measurement for.
But what if you like divided 6.3 divided by 3 and then added 2.1?
So right, and I'm trying to avoid going through all different kinds of calc. Just based on what they give me. No measurement, correct? Okay. However, I do have a medium measurement. It's h. And do I have a c, a hypotenuse measurement? C is like my hypotenuse. Okay. That would be 3.1. So, Matt, it's good thinking. I'm just trying not to take anything else into account here. Okay, looking at your medium triangle, this one right here, I want you to list the measurements they give you. Is it a question? Okay, so medium triangle. Do they give us the short side of the medium triangle? Yeah, it's h. I mean, it's a variable, but okay. Do they give us the medium side? No. Do they give us the hypotenuse? Yes, 5.5. All right. Now, in my big triangle, go ahead and label what they give you in your big triangle. Okay, do they give you the short side? Yes, what is it? Do they give you the medium side? 5.5. And do they give you the long side? 6.3. Now, the beauty of doing it this way and making this table, and I didn't really put this table together. Mr. Bogle, who's taught this for like over 20 some years now, he got sick of trying to teach it using geometric mean, which was really difficult when you get to these more complex ones. He thought, man, if I could just show the kids how to use proportions, it'd be a lot easier. Well, the benefit of this is it shows your proportions right away. All you have to really do is take a look at this now, and if you want to solve for h is to 3.1 as 5.5 is to 6.3. How did I get that? Well, I know that they're proportional. So this is taking my small triangle and comparing the longest leg to the hypotenuse. And this is taking a similar large triangle and comparing the longest leg to the hypotenuse. Question? No. Oh, you could. Sure. Yeah, go for it. Use SOHCAHTOA. Huh? Well, I mean, in order to use SOHCAHTOA, you have to be able to use your trig functions, and some people can't use them. Right now, they don't know. Okay, but that would work if you know your angle measures, right? Sweet, yeah. So what is this angle measure?
60.
Hey, smart guys, listen. What is the angle measure right here?
Oh, we have no idea.
Yeah, we have no idea. So can you use SOHCAHTOA?
No.
No, okay.
Not in this case. No.
That's
Oh, in the future you can. In fact, the next lesson is SOHCAHTOA. I know, it's like you predicted the future, man. All right, so here we go. Cross multiply. 6.3h is equal to 3.1 times 5.5, which is?
17.2.
17 point what? 0.5. Okay, and h is? 3 point what? 5. Is that true?
No.
No, because, yeah, 6 would, that'd have to be at least 18. That doesn't work.
2.7.
2.7. Okay, so let's go to the nearest tenth, which would be 2.7. Okay, the height is 2.7 meters. All right. All right, for those of you who started on 9.3 practice A, number 3, if I'm filling out my triangle, ABC, or excuse me, filling out my table, I have the small, medium, and large triangle. Okay. Short side I don't have for the small. Medium side I do. It's X. Long side is 9, or excuse me, 6. The medium triangle, this one here. Short side is X. Medium side I don't have, but the long side is 8. And then my big triangle, short is 6, medium is 8. And the long is 10. If I'm looking for my proportion, look for places where you have the same, or you have a similarity ratio. So 8 is to 10 as X is to 6. Or you could do 6 is to 8 as 6 is to 10. You could go this route if you wanted to. That is to that as that is to that, as long as they're at the same level. Okay, comparing the same side. Okay, so X is to 8. As 6 is to 10. That gives me 10x equals 48. So x equals 4.8.